Of Brad's article. 7 ways machine learning projects fail. And Brad's the CTO and co-founder, and I hope he joins me sometime on a Periscope conversation, because we need to explore this. We need to get the word out that there's a way to make these projects work, and so many people are not doing it. And I'm pretty excited because I've got a couple of proposals out, and what I've realized is that you can provide an on-ramp to machine learning and to AI for companies that's way more effective and actually shows what's going on. But here's this, and I felt a little bad yesterday because I had the 85% of AI projects fail, and there was a whole list of possible reasons, and I said these aren't really the reasons. Well, today's list is a better list by a long shot, but I can't say why a project fails. If you say, my car stopped running, why? There's a lot of necessary conditions needed for a car to run, but there's not fixing one of those bad situations may not be sufficient to get the car running. That's a whole philosophical position. In this case, though, I think these are all serious enough. The other ones were about communication and buy-in and all kinds of political stuff, and those matter. And I've been, kicked out of companies even after making them tons of money because somebody had another vendor they wanted to pick. So I'm not going to say those were wrong reasons. There's hundreds of reasons why a project can fail. I'm more focused on how to make a project succeed, and I'm sure Brad is also. So here's his list of 7: bad data, picking the wrong goal, explanation versus prediction, optimization without exploration, unanticipated data bias, not defining done, and picking the wrong time window. And so let's talk about these. Good data is essential to machine learning. Yesterday's article ended by saying most of a data scientist's work is cleaning the data. What a sad thing. And part of it's because they rake the Milky Way to get as much data as they possibly can, instead of starting with stuff that's absolutely known and most likely to have impact on customer decision making. That's a big difference. Okay? Start with what we are sure about and move to the periphery. And what you'll find is most of it doesn't matter at all. Most of it doesn't matter. I mean, very low causal impact. That's what we'll find. But I can tell you that, and you can listen, or you can decide you want a data project, a long-term data project. Now, what Brad says is that one way to solve consistency is to build a data lake or a data warehouse. We call ours a data mart because what we do is we take data right off your order processing system and we put it in our format, and we can take data from other sources. So we take data from Abacus the other day. We take Geodemographic. We take data from Epsilon, and you can add that in. Does it push the needle? Yes. Usually, it's so incomplete that it doesn't. It's not one of the better variables. So a lot of what we do is add geodemographic variables in, and most don't work, but some every now and then do. Okay, so it must be relevant, and that's what we look for. We look for the stuff that connects directly to the customer. Stuff you can generate from the ship to, stuff you can generate from the category of product purchased. Those kinds of things are solid. Okay, so Brad and I are on the same page. Now, the difference, I've been in a few RFPs and and studies. Hudson Bay flew me up and paid me $20,000 in 1994 to oversee a data analysis project in a scope, and we generated a book, the other company, about this big, and they sent it to me and they said, would you, we'll pay you to read it. Tell us what you think of their assessment of the project. I said, John, you've bought an Eiffel Tower. And he says, what's an Eiffel Tower? I said, well, what you're looking for is a bridge into machine learning. And this looks like a bridge, and it's built a lot like a bridge, but it will never get you in the direction you want to go. I thought it was a pretty good metaphor, actually. Anyway, so you can do RFPs till the cows come home, or you can hire somebody that's done it, for 25 years and absolutely knows where to start. So our data spec is like 9 pages. IT people are like, oh, hey, this is just a data dump. We can do this in 5 minutes. And sometimes we get data back. We just send the spec, and here comes data. We didn't even ask him for it hardly, and sometimes it comes on the thumb drive. Okay, this is another great one. Explanation versus prediction. If your business goal is to provide insight, then you want to keep things simple. Okay? Choices of the model must be kept simple. If your goal is predictions, then you can use neural net. And this, I believe, Brad, is a false dichotomy. It's because the two poles of data analysis are regression, simple, understandable, and neural net, which you point out. And you say you should choose. Well, we use one that's in the middle. We can throw 500 variables at it, but we also can understand what it's up to. It's fully transparent. So maybe you should, maybe you need a new tool. But so we don't have to decide. And we have 25 years of experience with the tool, so we can tell right away. You put the data in, you build a model, you can see what's wrong with the data. You can see there's a problem, which is an advantage because our structure reveals the anomalies rather than trying to guess what the data looks like before you analyze it. Okay? So, causation and correlation. Here's the trouble. With the more data you have, if you had a string of characters of pi, let's say 1 billion characters of pi, and you had a random number generator going to 1 billion characters, you're going to find long strings of correlation with no meaning whatsoever. So the next thing we do is we have a human look at the data, look at the model, and say, this doesn't make a bit of sense. There's no way that the percentage of disabled veterans in the over 65 population is going to be your most important variable. There's a big mistake there. There's no way all of your customers are going to be in the last 3 months buyers. There's a mistake there. And we spot those before we tell you, oh, crazy. So we know what makes sense and what doesn't make sense. And that's how you sort correlation from causation. That's the best way. But the second best way is establish causation by giving a fraction of your customers a different experience. Great! A/B test. Put it out in the real world. People use predictive models to recommend products, and they say, oh, it's way more effective than nothing. Yeah, true. But what about a good offer? They never do that. They never split test. Brad, you're right on the button. This is the greatest article I've ever read. This is great. Optimization with exploration, continually validating. Well, we iterate validations like 25 times every time. We let the human look at it. We send it to validation. We bring it back, find the anomalies, let the human. We also do every promotion, like one a month through the year, which also solves the time frame issue. Data bias, very similar to the causation and causal thing. And we set a timeline for the very first end of the first project within 3 months. So anyway, I am really excited about this article, and I want to commend it to you and commend Brad. And he's at retina.ai, retina like your eye.ai. And so you can set up a demo with him. And I highly, highly, highly recommend him because he obviously knows what he's talking about. I'm John Miglosh for the Wisconsin DMA and the International Society for Strategic Marketing. Like and share. Share shows you're smart.